All right, this is 4.4. Solve systems of equations with three variables. So we have the first is 3 dimensions. Up to this point, we have been dealing with two-dimensional lines. So now, if we draw lines out, just like this ones, into 3 dimensions, they can become walls. And just wherever you are, just look at the corner of the room, just like this image. But graphing in 3 dimensions is much harder to do. It would be very difficult because we would have x plus y plus z equal to, let's say, 4. So it's very, very difficult. So that's why we are we're gonna be drawing 2 dimensions. 2D. We're gonna be in the 2D world instead of the 3D. Okay. So let's first start with the type of solutions we can have. I don't know if you guys recall, in our 2D world, we have what? These two lines that are what? Parallel, right, to each other. And it could be like walls. If we were in a classroom, I would be able to show you this, the parallel walls that we would have. And then the second one, this is where two walls intersect in a line. Okay? And yes, parallel lines. And then this one is the one that intersects intersecting planes at a line. So this one, intersecting planes at a line, that would be like the bottom of the floor, is this one. And a straight line, we know what? It's infinitely many solutions and all points on the same line. And this one is intersecting planes at a single point, like the corner of the room again. And this one, we're going to have just one solution. So how do we solve it algebraically? I wrote it down here and I'm going to keep it. How do we do it? So we are going to go from a system of 3 variables. We're going to draw it down to what? To 2 by 2 system. 2 of the same variables. Down to what? To 1x times 1x system of variables. To find the third variable. I will go over this with the example that I have here. Okay, hold on. So here's the example. And we're going to keep this handy. So the first one says 2x plus y minus 3z equals to 7. We have x minus y plus 2z equals to 0. and we have 3x plus 2y minus 5z equals to 11, okay? Now we need to choose a variable to fully eliminate first. Okay? So I'm going to, let's say I chose y. And the second equation is very nice, this one. So I use it twice. Okay? So the second equation y is very nice because of there's no coefficient on the x and the y. I'm going to use it twice. All right? So let's do it. So I have the first one is 2x plus y minus 3z equals to 7, right? So here comes the second equation, which is x minus y plus 2z equals to 0. So if I add this, what do I get? I get a 3x, what is this? 0. And I get a negative z equals to 7, right there. Now, I'm going to take this third one and I'm going to combine it with the first one. Let's do that. So the second one is 3x plus 2y minus 5z is equal to 11. So I took this one and this one. Now I'm going to take this one and this one. X minus y plus 2z equals to 0. But what do I need to do here? In order to eliminate the y, I need to multiply by what? By negative 2. By 2, sorry. So 2 times 2, and this one will be what? Times 2 and times 2. So 3 plus 2 will be 5. This is 0. I have negative 5 plus 4. That will be negative z. 0 times 2 is 0. So I have 11. Now I have two equations. So I went from 3, a system of 3 variables, to 2 of the same variables, down to this one. I just did it. Now we are gonna go from here. Remember that I use all 3 equations to eliminate y. I'm just writing it down so you guys know there. Now I'm going to take these 2 equations. So it's going to be 3x minus z equals to 7 and 5x minus z. What do I need to do here in order to eliminate? What is going to be easier for me to eliminate the z, right? So what I need to do is multiply it by negative 1. That's all I need to do. If I do that, this is going to be negative 5. So I'm going to have negative 2x. This is going to be positive z plus negative z is 0. This is going to be negative 11 plus 7, negative 4. And this is going to be equal to x equals to 2. So I just went from 2 to 1. So we started right here. We started with 3 by 3 system of equations. We went down to what? 2 by 2. Okay? And then what do we get? 1 by 1, which is this one. All right. Now we are going to back up. Okay? So just like it says here, once we're here, we're going to start going back. So if x is equal to 2, and we know that 3x minus z is equal to 7, or we know that 5x minus z is equal to 11. So we will know z, okay? And we could replace it on either equation. Then, do we know z? Yes, we do. And we're gonna replace it on either one. We'll do both, that way you guys see. 2 minus z equals to 7. So this is 6 minus z equals to 7. And if I do this one, will be 5 times 2 minus z equals to 7. So this is going to be 10 minus z equals to 11. And either way, if you guys do it, let's say we subtract the 6. So it's going to be negative z equals to 1. And z is going to be equals to negative 1. And here we'll do the same thing. And this is going to be equals to 1 and z equals to negative 1. So either way is negative 1. Z is equal to negative 1. Now that we know that one, remember we said here, then we go back to this one to we use it to find the third variable. So we're going to do that. And oops. Now that we know so now that we know, what do we know? X is equal to 2. And we know that z is equal to negative 1. So, do we know why? Yes. Either one, we could do it. Let's start with, here's the first one. 2x plus y equals to 3z equals to 7. The next one was x minus y plus 2z. And the last one was 3y plus 2y minus 5z equals to 11. I'm writing all of these ones down again. So I know x is equal to 2 and z is equal to -1. So let's use that. So we know that 2 is going to be times 2, all right? Plus y, I don't have y, that's the one that I'm gonna find from here. And z is what? -1. And all of this is equal to 7. So this is 4 plus y plus 3 equals to 7. This is 7 plus y equals to 7. So y is equal to 0. Now let's do this one. This is 2. I don't have y. And this is -1 equal to 0. So this is going to be 2 minus y minus 2 equal to 0. This will be what? So this is 0 minus y equals to 0. So y is equal to 0. Now, let's do the last one. This is 3 times 2 plus 2y minus 5. And 5 is going to be multiplied by -1. And that's equal to 11. So this is 6 plus 2y plus 5 equals to 11. 6 plus 5 is 11 plus 2y is equal to 11. So what do we get? Y is equal to 0. So each way that we did it was y equals to 0. So the solution is that the planes intersect at a single point. So we can say the planes intersect at a single point, and that point is 2, 0, -1, which is x, y, and z. All right. I do have a couple more exercises that I'm going to do. Let me check really quick if they are. Yes, one of them is part of this package that I mentioned to you guys. So so is 5x is equal to 5. 2x plus y is equal to 4. And 3x plus y minus 4z is equal to negative 15. All right. And we need to find our x, y, and z point. All right. So first, I'm going to take this one, the first one, because I need to. I'm going to get my x from there. So how do I do this? We know by making a 1 multiplying by the reciprocal. So x is equal to 1. All right, I just found 1. Now, having this one, I can go and substitute this one into this one. Not this one because I will have 2 unknowns. So I'm going to use this one. So I know that 2x plus y is equal to 4. And this is what I just got for x. So I'm just going to substitute 2 times 1 plus y equals to 4. All right? And this is 2 plus y equals to 4, making a 0. Y is equal to 2. So my y is equal to 2. Now, let's get the z. I have this one and this one, x and y. All I need to do is find z. 3x plus y minus 4z equals to negative 15. So this is this one and x is this one. So what I do here is 3 times what? Times 1 plus y is 2 minus 4z equals to negative 15. So I have a 3 plus 2 is a 5, negative 15. So I'm going to make a 0, and I have a negative 4z equals to negative 20. If I multiply by the reciprocal, I get a 5. So this is going to be, so I found the point 1, 2, 5. All right. Now, let me see what else I have. I have, no, this one is exactly the same as the one I just did. And let's do this one. X plus, no, we don't have that. Okay. Let's do this example. We have, this is part of your package, okay, guys? So you can find it there. Equal to 8. And we have 2x minus y minus z equal to 10. This is like the first one that we did. Okay. So we need to come up with all of them. 1, 2, and 3. X, y, and z. So now, I'm going to take this one, the first one, and I'm going to add it to this one. Because I could eliminate the white. plus z equals to 8. And 2x minus y minus z equals to 10. And what happens here? I end up eliminating two of them. So this is going to be 3x is going to be equal to 18. So what do we have? X equals to 6. Got my x. There we go. Got one down. If I go, let me see what else do we do. I could take this too. And this is going to be 12. Let me see. Yeah. Let's go down like this. So then if I replace this x equal to 6 on this equation, so it's going to be 2 times 6 minus y minus z. So this is going to be 12 minus y minus z equals to 10, right? And I can go ahead and replace it on this one too. So it's going to be what? 6 minus 2y minus 3z equals to 22. Okay, so first I use this two, and then I'm using this two now. What can I do there? In order to eliminate the y, or what do I want to, you know what, right here I need to combine like terms. So let me do that first. Hold on. Let me combine these terms. So then if I make a 0, so this is going to be negative y minus z equals to what? To negative 2. Okay. So this is one equation that I have. And let's do the other one. The other one, we said we were going to use the x minus 2y minus 3z equals to 22. So this is 6 minus 2y minus 3z equals to 22. So let's make a 0. And what do we have? We have negative 2y minus 3z. 22 minus 6 is 16. Here we go. Now we have these two equations that we can work with. All right. So let's write them down. These two, we're going to add them. So we have negative y minus z. Let me do it on another piece of paper. Negative y minus z equals to negative 2. And negative 2y minus 3z equals to 16. So what we need to do is multiply this one by what? By negative 2. Because if I multiply this one by negative 2, what do I get? I get positive 2y, and then I could replace it. I could cancel it. I could eliminate it, okay? So let's do that. So it's going to be 2y plus 2z plus 4. And this one is going to be negative 2y minus 3z equals to 16. There we go. So here we go. We have our 0. Here we have negative z equal to 20. And z is going to be equal to negative 20. So we got the x and the z so far. So now what we need to do is go back and use this one to replace it. So we have x plus y plus z is equal to 8. So we know x is 6. Y, we don't have it. And z, we know is negative 20. Okay? So 6 minus negative 20, that's negative 14 plus y equals to 8. And if we make a 0, we get y equals to 22. Okay? So first, what I did, my first step was I took these two equations and I add them. Cancel y and the z. Having the x equal to 6 right away. So what I did was I went back and I replaced it on two of these ones, okay? On these two. First I used these two, now I'm gonna use these two. When I got them together, z equals to negative 20. Then I went back to number 1 and I replaced it to find y equals to 22. That's what I did there, guys. Let me know if you have any questions. You can just come to my office hours or just email me and I will send you a Google Meet, a Google invite, and we could meet. All right? Thank you.